So in this video, I'm going to explain the next logical instruction, which is CPI. So the meaning of this CPI is compare immediate with accumulator. So here in this instruction, what it is going to happen, it is going to compare the content of accumulator with 8 bit of immediate data specified as a part of the instruction. So here their opcode will be what? Their opcode is CPI. Their opcode is CPI and their operand will be 8-bit data. So their mechanism of the functionality will be very similar as like CMP itself, what I had explained in the previous video. So here how this carry and zero flag are used to reflect the result. So it is happening in the similar way. So here we can say that if accumulator content is greater than data, then what will happen? Their carry flag will be reset and zero flag will be also reset, because it is like a content is greater than data. It means there is no carry or borrow required for the subtraction. So due to that reason, their carry flag will be reset and the result of this subtraction will be positive, that is non-zero. So that is the reason their zero flag will be also reset. So now here as a second case, what will happen? That will be if there are two numbers, then only three possibility, that first number will be greater than the second number or both the number will be same. In the third case, that first number might be lesser than the second number. So here as a second case, if this content of the accumulator is equal to the content of this 8 bit of immediate data, then by that time also their carry flag is reset, because no borrow or carry is required to perform the subtraction, and the result of this subtraction will be complete zero. So that is the reason this zero flag will be set here. Zero flag will be set here. And as a third case, if accumulator content is lesser than this data, then what will happen? That carry flag or borrow it is required. So due to that reason, their carry flag will be here set and the result will be non-zero negative. So that is the reason their zero flag will be reset. So these two flags are required to show the result of this comparison, but as a effect of this instruction, it is not going to store this subtraction result into the accumulator as like CMP. So here these things, and we can write that like in the note, we can write about the flags. So remaining flags means apart from carry and zero, there are sign flag, then there will be parity flag, auxiliary carry flag. So these are modified as per the result, that is subtraction result, and carry and zero flags used to reflect the result, whether it is greater or lesser, that can be or equal, that can be identified by testing this carry and zero flag. So we can say that carry and zero flags used to reflect the result. This is the very important point here to understand this. So now we can understand this with some example. So let's say I am taking here the example as a CPI. For example, let's say for example, this instruction I am taking here as a CPI 98H. CPI 98H, and here I'm assuming that the data is 98H here. So the accumulator content before execution of this instruction, I'm taking here as a C2H, and this 8 bit of immediate data as a part of this instruction I have taken here as a 98H. So it means here what the operation has to perform. Here this data will be subtracted from this accumulator content, and as per the result it will reflect over the flags. So here this A is taken as a C2H. So this A is equal to C2H. So this can be written here in the binary form as a 1100, and this 2 can be written as a 0010. Now the next part is we have to take the 2's complement of this data. So here how to perform this subtraction? So this can be performed here, A plus 2's complement of data. So that is equal to minus 98H. So minus 98H can be added to C2, that is giving here the subtraction of 98 from C2. So here this data is taken, this data is 98H. So their binary pattern can be written 1001. This is here 9, and then for the 81000. So now we need to take their 2's complement. So 2's complement of data is equivalent to minus 98H. So here this 0 will be copying as it is. So this will be 0, this will be 0, this will be 0, and the first non-zero is here as a 1. After this, that bit will be altered. 1 will change to 0, 0 will change to 1. Then we will get their 2's complement directly. So this 1 will become 0, this 0 will become here 1, then this 0 will become here 1, then this 1 will become here as a 0. So now this data, whatever we had taken, data is now as a minus. This is the representation of what? It is the representation of minus 98H. So here we can write minus 98H, and now their binary equivalent, it is coming here as a 0, 1, 1, 0, then 1, 000. So now we need to add these two. So that is giving the subtraction of these two data, two values here, two numbers here. So 0 plus 0, it is giving here as a 0 from this stage, from the first stage. Then again 1 plus 0, it is 1. From the third stage, 0 plus 0, it is 0. From the fourth stage, 0 plus 1, it is 1. From the fifth stage, 0 plus 0, it is 0. From the sixth stage, 0 plus 1, it is 1. From the seventh stage, 1 plus 1, some bit will be 0 and carry bit will be 1. So here 1 plus 1 plus 0, sum will be 0 and carry will be 1 here. So as per the rule for this 2's complement subtraction, what I had explained earlier, whatever is the carry bit, it should be complemented as a final result. So here we can write complement carry. Complement carry, it means now this will become here as a 0 and remaining result bit will be same. So this will be 0, 0, 1, 0, 1, 0, 1, 0. So as per this result, as per the result, their flags is going to be changed. So that we will see it here. This is sign flag, 0 flag, auxiliary carry, then parity, then carry. So here, if we'll see that their MSB bit is 0, so this sign flag will be 0 here. Result is non-zero, that is the positive value, because C2 will be greater than this 98H. So this is the accumulator. So accumulator content is greater than this data, whatever we had taken 98H. So that is the reason their result will be non-zero positive value. So that is the reason their 0 flag will be reset here. From the fourth stage, there is no carry generated which would be added to the next stage. So that is the reason, if no carry, it means auxiliary carry will be also reset here. Then this parity flag. So if you'll see that in this subtraction result, the number of ones is 3 here. So that is called odd number. So due to that reason, their parity bit will perform as a odd parity. So odd parity means parity flag will be 0 here. And as per this final carry operation here, so this carry flag is 0. So here this carry flag will be 0. So accordingly, as like this, there will be impact over the flags, but accumulator content whatever we had taken, so after execution of this instruction, the accumulator content whatever we had taken as a C2H, it will be same here. It will be same here. So this subtraction result is not going to be stored into this accumulator. Subtraction is used by the processor internally to compare these two values whatever we had taken as a content of the accumulator and the data. So these two values will be compared, and according to the result it is going to reflect over the flags. So this 0 flag and this carry flag, so testing of these flag values will say that whether this accumulator is greater than the data or lesser than the data or equal to the data. Accordingly, we can find out. So I hope you understand their operation. Now we'll see about this rest part as a size, machine cycle and T state. So here, for example, whatever we had taken as a CPI 98H. So this consists of English alphabet as a opcode with 8 bit of data. So opcode will take here 1 byte, and this operand as a data 98H will take another byte. So to store this instruction into the memory before execution, it will occupy 2 locations. So that is the reason each location is 8 bit of size or 1 byte of the size. So their size for this instruction, it will be 2 byte here. So let's say, for example, if I am taking their starting address of this instruction is 2000H. So at this 2000H, it will store here their opcode. So let's say their opcode CPI and their hex equivalent is FEH as per their record, and at next location there is the data which is 98H. So these two memory location is required to store this instruction before execution. It means it is taking 2 memory location, each location is 1 byte. It means total location occupied is 2 or 2 byte here we can say. Now as a machine cycle, so first of all it will take this opcode. So first operation will be opcode fetch machine cycle. Then while doing that decoding and execution of this opcode, the microprocessor is going to know that the next byte will be their second operand, which is going to be compared with the content of the accumulator, and as per the subtraction result it is going to change their carry and 0 flag. So as per the status of carry and 0 flag, user or programmer can identify which one is greater, whether accumulator content is greater to data or equal to data or lesser than data. So that can be identified by testing the result of this carry and 0 flag status. So first machine cycle will be opcode fetch, and the second machine cycle will be memory read, because we need to read this second operand from the memory. So that is called here as a memory read operation. So combinedly it is required 2 machine cycle for the complete execution of this instruction. So for this opcode fetch, by default it is required 4 T state. For the memory read it will take 3 T state. So total number of T states for the execution of this instruction will be 7 T state. 4 plus 3 7 T states. So the major point is that we need to keep it in mind that carry and 0 flag are used to test about the result. Rest of the flags are modified as per the subtraction result. And the key point is, after execution of this instruction, it is not going to change the content of accumulator. So the subtraction result is not going to be stored into the accumulator. It is just for internal purpose. So I hope you understand this instruction operation and impact of the flags with much of clarity. Thank you.